Hey everyone, in this video we're going to be looking at Chapter 7 of Effective Engineer, which is called Improve Your Project Estimation Skills. The first section is called Use Accurate Estimates to Drive Project Planning. It talks about the importance of estimating software projects and gives strategies for making them. The author emphasizes the distinction between estimates, which reflect the best guess of how long or how much work a project will take, and targets, which capture the desired business goal. Often, project schedules slip because the target alters the estimate, leading engineers to shoehorn necessary work into an unrealistic project plan. To produce accurate estimates, the author suggests decomposing the project into granular tasks, estimating how long tasks will take, thinking of estimates as probability distributions, letting the person doing the actual work make the estimate, and using multiple approaches to estimate the same task. The author also cautions against anchoring bias, where an initial estimate sets an anchor that makes it hard to establish a more accurate estimate later on. The next section is called Budget for the Unknown. Software projects often miss their deadlines due to factors beyond a lack of talent or motivation. At Uyala, for example, the engineering team could not deliver a player rewrite on time, as they had underestimated timeframes for individual tasks and not accounted for unknown projects and issues that occurred during the project. These included debugging video corruption issues, firefighting scalability problems, and rewriting user interface components from scratch. While these issues were surmountable in isolation, their compounded effects wreaked havoc with the project schedule. The net result was that the team's development speed slowed down even more after missing the original delivery date. In his book, The Mythical Man Month, Fred Brooks explains that this experience is a general pattern in slipped software projects, where little decisions and unknowns cause a project schedule to slip slowly, one day at a time. To deal with unknowns, it is important to acknowledge that the longer a project is, the more likely it is that unexpected problems will arise. It is also essential to separate estimated work time from calendar time. Deadlines often catch people by surprise because they conflate statements like, "This project will take 1 month of engineering work to complete," with, "This project will be completed in 1 calendar month." Additionally, interruptions such as bug fixing days, hackathons, offsites, or performance reviews, mandatory downtime of core developer services for upgrades, maintenance, or data migrations, and the need to fix unexpected outages or high priority security bugs can throw off the project schedule. As a result, it is necessary to build in buffer time for unexpected interruptions when setting schedules. Therefore, it is essential to be explicit about how much time each member of the team will realistically spend on a given project per day. For instance, Asana's engineering team maps each ideal engineering day to 2 work days to account for daily interruptions. By taking these steps, you can better deal with the unknowns and interruptions that arise during a project, ensuring that it can be delivered on time. The next section is called Define Specific Project Goals and Measurable Milestones. In the tech industry, projects can easily slip behind schedule due to a lack of clear understanding of what constitutes success. This can make it difficult to make effective trade-offs and assess whether a project is on track. The solution to this problem is to define specific goals for a project based on the problem being solved and to use milestones to measure progress towards those goals. One example of this strategy in action was Tamar Berkovici's management of a large infrastructure project at Box, a cloud storage company. Berkovici's team faced a critical scaling challenge in late 2012 when their entire application database resided on a single MySQL database instance. Database traffic had grown to nearly 1.7 billion queries per day, and the team knew that they would outgrow their architecture's capacity in a few months. After researching potential scaling options, Bercovici and her team kicked off a project to shard the massive folder and file tables. The goal was to horizontally partition the two tables so that they could store the partitions or shards on different databases. Under a sharded architecture, they could accommodate future growth simply by splitting the data into more shards, moving them to additional database machines, and updating the lookup table. The project was time-intensive and involved modifying large swaths of their 800,000-line codebase. Every code path that queried one of the two tables needed to be modified and tested. It was also a risky project that had the potential to grow in scope and slip behind schedule. Bercovici used a key strategy for reducing risk. She articulated a clear goal for her project based on a clear problem. Her goal was to migrate to a sharded architecture as soon as possible without any downtime. This simple exercise of setting a project goal produced two concrete benefits. First, a well-defined goal provided an important filter for separating the must-haves from the nice-to-haves in the task list. Second, it built clarity and alignment across key stakeholders, helping team members be more accountable for local trade-offs that might hurt global goals. The more specific the goal, the more it can help discriminate between features. Some examples of specific project goals include reducing user latency for the home page, launching a new search feature, porting a service to a different language, redesigning a web application, building offline support for a mobile application, A/B testing a product checkout flow, and developing a new analytics report. The next section is called Reduce Risk Early. It notes how engineers may prioritize easier tasks in a project and ignore the riskier areas, leading to a false sense of security. To effectively execute a project, it is important to minimize risk by identifying issues early on and tackling the riskiest areas first. System integration is a common risk in large projects, and building end-to-end scaffolding and doing system testing earlier can reduce integration risk. By shifting work that can take highly variable amounts of time to earlier in the process, engineers can reduce risk and make more effective project plans. The next section is called Approach Rewrite Projects with Extreme Caution. Software engineers often have the urge to rewrite a software system from scratch, whether to address technical debt, add new features, or make it cleaner. However, rewrite projects are some of the riskiest projects, with a high potential for timelines spiraling out of control and the cost growing with the project's duration. In addition, rewrites tend to be more complex than the original system, and the, quote, second system effect can cause overdesign and schedule delays. Engineers who succeed in rewriting systems do so incrementally in controlled phases. Incremental rewriting reduces the risk of introducing errors and allows engineers to refactor a system over an extended period of time. It provides additional flexibility to shift to other higher leverage work at each step. Engineers should use a series of incremental behavior-preserving transformations to refactor code, which reduces the risk of introducing errors. Breaking a rewrite project down into separate targeted phases is also a good approach when incremental rewriting is not possible. This approach helps to address ongoing customer issues and complete the rewrite. The next section is called Don't Sprint in the Middle of a Marathon. The author describes his experiences working on two major projects where the engineering manager pushed the team to work overtime in a sprint to the end. Despite having talented and dedicated team members, the projects were not completed within the given time frame. The author notes that it is important to understand how to deal with projects with slipping deadlines, and that working more hours doesn't necessarily mean hitting the launch date. He goes on to explain the reasons for this. Firstly, research has shown that hourly productivity decreases with additional hours worked. Historical experiments found that overworking employees can lead to a decline in productivity, while instituting a 40-hour work week can actually increase total worker output. A 1980 study also found that the cumulative effect of decreased productivity from overworking can cause a delay in completion beyond that which could have been realized on a 40-hour work week. Secondly, slipping deadlines often mean that the work in previous months was underestimated, and this underestimation likely extends to the entire project, including the remaining time. Estimating the end of projects is more difficult, and unexpected issues can throw schedules off by a week or more. Thirdly, working extra hours can burn out team members who may be sacrificing time that would otherwise be spent with friends or family, exercising, resting, or sleeping. This can lead to a hard-to-quantify risk of burnout, which can result in errors and accelerated turnover. Fourthly, working extra hours can hurt team dynamics. Not everyone on the team may have the flexibility to pitch in for some extra hours, which can result in bitterness or resentment between members of the team. Fifthly, communication overhead increases as a deadline looms. The team may hold more meetings and share more frequent status updates to ensure everyone is working on the right things. The additional coordination requirements mean that people have less time to devote to the remaining work. Lastly, splinting towards a deadline incentivizes technical debt. Teams may cut corners to hit milestones, resulting in a pile of technical debt that they have to pay off after the project is over. The author concludes that overtime is not a panacea for poor project planning, and that it comes with high long-term risks and costs. Unless there is a realistic plan for hitting the launch date by working extra hours, the best strategy in the long run is either to redefine the launch to encompass what the team can deliver by the target date, or to postpone the deadline to something more realistic. However, the author acknowledges that at times a small dose of overtime may be necessary to hit a key deadline. In such cases, it's important to have a realistic plan for actually hitting the launch date by working extra hours. The author also suggests that having an open and honest conversation with team members about the pros and cons of working extra hours can help mitigate some of the risks associated with overtime. With all that being said, the key takeaways for this chapter are to do your riskiest tasks first, define measurable milestones, allow buffer room for unknowns to come up, and know the limits of overtime. So that's all for this one. My name is Daniel, and I make programming-related videos, sometimes coding tutorials, and others more abstract, like book chapter summaries. I do it not only because I love teaching you, but I love learning for myself as well. So if you found this video and this series helpful or thought-provoking, I'd appreciate a like, subscribe, and comment. I love hearing from you, and we'll see you all in the next one.